Today we're going to be doing operations with complex numbers. A complex number is written as a plus bi, where a is the real part and bi is the imaginary part. So here are some examples of complex numbers. 7 plus 2i, 900 plus 67i, negative 3 minus 2i. These are examples of complex numbers. Today we're going to be doing operations with complex numbers. Adding, subtracting, and multiplying. We're going to save dividing for a different lesson. So here we're going to add two complex numbers. So your numbers will go together, the real part goes together. So negative 11 plus 9 is negative 2, and you're going to combine the imaginary part. 3i plus 2i is 5i. Here we're going to add, so we have 4 plus 7 is 11, and then I minus a 5i is negative 4i. So this is your new complex number. Here are some examples with subtracting. This minus sign needs to go to both the 2 and the 6i. So this will be minus 6i. And I'll bring this part down. So we'll combine the real parts. 9 minus 2 is 7. Negative 2i minus 6i is negative 8i. This says 6i minus 14 minus a negative I is a plus I, plus 7, and then a minus 4i. We're going to combine all the real parts. So negative 14 plus 7 is negative 7. 6i plus I is 7i, minus 4i is 3i. So this would be your answer. 2i times 8 is 16i. 2i times a negative 3i will be negative 6i squared. Now let me remind you of an important fact. I squared is equal to negative 1. This is what you have to have memorized. So I have 16i minus 6, and remember, I squared is equal to negative 1. So I have 16i, a negative 6 and a negative 1, this becomes a positive 6. So this is your answer. I like to put the real part first and the imaginary part last. This is the proper format. A plus bi. Let's do this one. This squared means you're doing 6 minus 3i times itself. 6 minus 3i. You have to write it twice since it's being squared. 6 times 6 is 36. 6 times negative 3i is negative 18i. Negative 3i times 6 is negative 18i. Negative 3i times negative 3i is a positive, because two negatives make a positive. 3 times 3 is 9, and I times I is I squared. Remember, I squared is negative 1. So this is 36 minus 18i minus 18i plus 9, and the I squared is negative 1. You can combine the middle terms. Negative 18i minus 18i is negative 36i. Everything else can come down. Also, a 9 times a negative 1 is a negative 9. So I'm going to combine my real parts. 36 minus 9 is 27. And then you have the imaginary part. So this is your answer. Two complex numbers in the form a plus bi and a minus bi, they're called complex conjugates. So this is an example of a complex conjugate. I have 4 plus I and then 4 minus I. This is in this format right here. These are called complex conjugates. When you multiply two conjugates together, you will always get a real number. So let's see how that works. 4 times 4 is 16. 4 times a negative I is negative 4I. I times 4 is a positive 4I. I times a negative I is a negative I squared, because there's 2 of them, so it's squared. Notice that this middle term cancels out. Negative 4I plus 4I is 0. So I'm left with 16 minus I squared. And remember, I squared is equal to negative 1. So I can replace this I squared with a negative 1. Well, these two negative signs make a positive. So 16 plus 1 is 17. So notice when I multiplied two conjugates together, I got a real number, and that will always be the case. And it's called a conjugate because you have a minus and then a plus. Same exact thing, but one has a minus sign and one has a plus sign. So they're called conjugates, complex conjugates. Okay, so let's go ahead and multiply them. 3 times 3 is 9. 3 times 4I is 12I. Let's do this one now. Negative 4I times 3 is a negative 12I. Negative 4I times a positive 4I, a negative and a positive will be a minus, a negative. 4 times 4, that's 16. I and I is I squared. Notice 12I minus 12I is just 0, so that middle term is gone. I am left with 9 minus 16I squared. Remember, I squared is equal to negative 1. That's important to remember. So I can replace this I squared with a negative 1. Everything else can come down. So a negative 16 and a negative 1, that's a positive 16. So 9 plus 16 is equal to 25. So when you multiply two conjugates together, you always get a real number. Let's try this one. Negative 7 times negative 7 is 49. Negative 7 times negative 2I is positive 14I. 2I times negative 7 is negative 14I. 2I times a negative 2I will be negative 2 times 2 is 4. I times I is I squared. And notice, this middle part will cancel out because 14I minus 14I is 0. So I'm left with 49 minus 4I squared. And remember, I squared is equal to negative 1. So I can replace this I squared with a negative 1. Negative 4 and a negative 1 makes a positive 4. So my answer is 49 plus 4 is 53. So again, I multiplied two conjugates together and I got a real number. Now we're going to solve. So I have all of this squared. So to get rid of the squared, I'm going to take the square root of both sides. So I am left with x plus 2 equals plus or minus. The square root of 81 is 9, and the square root of a negative is I. Because remember, the square root of negative 1 is equal to I. From here, you're going to subtract 2 from both sides. So my final answer is x equals, I like to put the real number in the front and the imaginary number in the back. So these are your two answers, -2 plus 9i and -2 minus 9i. Okay, we need to get this part by itself. The part that's being squared needs to be alone. So I'm going to multiply. This is being divided by 4, so the opposite is to multiply by 4 on both sides. Also, this is being multiplied by a 3, so the opposite would be to divide by 3. So guys, you just multiply by the reciprocal. If it's multiplying by 3/4, you multiply by 4/3. So those cancel, and we'll multiply this part. I'm left with x plus 3 squared equals -96 times 4/3 is -128. From here, now that I have something squared, I can now take the square root of both sides. I am left with x plus 3 equals plus or minus this square root of -1. I'm going to have an I since there's a negative number inside. And then I have the square root of 128. So let's go ahead and break this down. I'll do my math over here. Let's break down this, square root of 128. I know that 2 times 64 is 128. 64 can be broken down into 8 times 8, and I can stop there. This is a pair, so that will go outside, and this is by itself, so that's just a 2. And don't forget this I on the outside. So that means this is x plus 3 equals plus or minus 8i square root of 2. The last thing we're going to do is subtract 3 from both sides. So my final answer is x equals, I like to put the real number first and the imaginary part in the back. So that it is in the proper format. A plus bi. And since we have two answers, plus or minus bi.